Okay, grade 8, now we are doing similarity. We are specifically looking at the similarity in triangles, but we're looking at the geometry of 2D shapes, right? So a similar triangle are triangles that the only difference is size, right? So they have the same shape, they could be a different rotation, but they have a different size. So they can be translated, rotated, or reflected, but they have a different size or scale. So the scale is different, but the ratios are exactly the same. So what do I mean? This triangle here, A, B, C, X, Y, Z, this could be times by a scale of 2. 2A, 2B, 2C. So this has been doubled in size. But look, X, Y, and Z are still exactly the same. So the only difference here is size. It could be a smaller. This is halved in size. So it's a half A, a half B, a half C. We've changed it by a scale. The X, Y, and Z are still exactly the same. So this is a similar triangle. This triangle has been rotated from there to there, but it's exactly the same scale as this triangle. It's just been a half smaller, but this is still a similar triangle, although it has been rotated. So the main difference is the size, or the only difference, but it can be translated, reflected, or rotated. So this is also similar. But the angles are always the same. X, Y, and Z never change for similar triangles. We're going to learn next year specifically that AAA stands for angle, angle, angle. And this is a proof of a similar triangle. If we have a triangle and we want to prove whether these two triangles are similar, we can simply see that these are similar, which we put with 3 lines, like an equals, but with an extra line, because X, Y, and Z are all the same. So these are similar triangles. The angle, angle, angle is the same. Okay, let's look at resizing of triangles to make them similar. We have a triangle. We now resize this triangle to make it into a bigger triangle. This is not a congruent triangle. Why? Because the lengths are not the same. That is not equal to that, right? But it is similar because we've just simply resized or enlarged or changed the scale of the triangle. We could rotate this triangle and it will still be a similar triangle. Now it is also congruent because we've rotated and enlarged the triangle. So here we rotated the triangle and enlarged it. It is not a congruent triangle compared to this one, but it is similar. So it is still a similar triangle. So congruency or congruent is to only rotate or translate or reflect. You've got to either do one out of these 3 things for it to be congruent only, right? But for similar or similarity, you've got to also resize it or only resize it. But it has to be resized for it to be a similar triangle. Okay, let's look at some examples. What triangles are similar? We have our triangle, our 4, 5, 3 triangle. As you most likely know, there's a right angle in this triangle. Where's that right angle? Right over here. But that's not too important for this video. So we have A, B, C, and D. Is this triangle similar to this triangle? Okay, now remember, if it's similar, it has a scale between the lengths. So so we say 8 over 4, right, must equal 10 over 5. So I'm going to put a circle around 8 and 4. I'm going to put a square around 10 and 5. And that must equal 6, I'm putting a triangle, over 3. And you can see that 8 over 4 is 2, 10 over 5 is 2, and 6 over 3 is 2. Good. This must be congruent. You can see the scale is 2. We've doubled this in size. 4 times 2 is 8, 5 times 2 is 10, 3 times 2 is 6. Okay, what about this one? Okay, let's check that scale. Let's now go 2 over 4. So we go 2 over 4 is equal to a half. Cool. What about 5 over 2.5? 5 over 2.5, oh sorry, 2.5 over 5 is equal to a half. Cool. We got to check the last one, 1.5 over 3, 1.5 over 3, and that is also equal to a half. Great. So this is also similar triangle because we have shrunk it by a half, or we've halved the size of the triangle. Let's now look at this triangle, 6, 7, 4.5. Okay, we can see that this is the smallest, it must be this one. This is the next biggest, must be this one, and then we have 7, which is the biggest. Okay, so let's check. What is 7 over 5? 7 over 5 is 1 and 2 over 5. What is 2 over 5? 2 over 5 is the same as 1 and 4 over 10, which is the same as 1.4. Okay, so that is the scale. Let's now check, how about we check 4 and 6. So we put 6 over 4. Remember, it doesn't matter which you put over as long as you do it for the same each time. So there I've done 7 at the top and 6 at the top, and then 5 and 4 at the bottom. 6 over 4 is 1 and 2 over 4. Okay, which is equal to 1 and, what is that, 5 over 10, which is equal to 1.5. Oh no, these are not similar triangles. The scale is not the same. So number B is not a similar triangle. Oh, let's have a look at this one. 3, 5, 4. Oh, we've changed these around, it looks like. But what has happened here? This has just been reflected and rotated. It is still a similar triangle though, because the ratio is simply 1. So there's 3, there's a 4 and a 5, and this is our triangle here. The scale, it was increased by a scale of 1. Okay, let's look at another example. We have a triangle here. Let's make this triangle 3 times larger, right? And then we're going to make it 2 times smaller. So, are these triangles similar? Let's first look at this first triangle. We're going to make it 3 times bigger. So we're going to times everything by a scale of 3. So we're going to go 7 multiplied by 3. That is equal to 21. 21. 13 multiplied by 3. That is equal to 39. So that's going to be 39. And then 6 multiplied by 3. We've got a constant scale. Is 6 multiplied by 3 is 18. And that's going to be 18 over there. Okay. Now let's look at this triangle. We're going to make it 2 times smaller. So we're going to have to times this all by a scale of a half. So we're going to go 7 times 1 half. Half of 7 is 3.5. That's going to be 3.5. 13 multiplied by half. What is half of 13? Do you know that? That's 6.5. 6.5. And then 6 multiplied by a half, or divide by 2, is equal to 3. And that is 3 on this side over here. Are they similar? Of course they are similar, because we've times it by a constant scale. On this triangle it was all times by 3. On this triangle it was all times by half. Because we did it to all 3 sides and not just 2 of the sides or 1 of the sides, it is of course a similar triangle. Well done grade 8, that was similarity, and now we're going to go on to congruency.